complex numbers. This is a topic we've kind of been dancing around for a couple of weeks now, so time to deal with it. So these are numbers that are not real numbers, which means they don't exist on a real number line, but they do still have real-world applications, so they're often called imaginary numbers. So what we do is start off defining the imaginary unit I, and how we define it is saying that I squared is equal to -1, and that I is the square root of -1. So I is just a symbol to take care of a particular situation and make the notation a little easier to work with. So all of our other non-real numbers can be written as multiples of I. So say the square root of -4, what we can do with that is split that up into 4 times -1 is -4. So this is the square root of 4 times the square root of -1. The square root of 4, of course, we know is 2. And then by definition, the square root of -1 is I. So that one cleans up pretty nicely. Square root of -3, we can break that into -3 is 3 times -1. So then we have the square root of 3 times the square root of -1. The square root of 3 we really can't do anything with, but the square root of -1 by definition is equal to I. So this is the square root of 3 times I. I'm kind of old school, so I'm used to writing the I after the square root, but it is more the common trend to write it as I times the square root of 3. The reason why we've kind of gone to doing this is sometimes it's hard to tell where your square root symbol stops, and you want to make sure that the I doesn't sneak inside your radical at all. So a shortcut to this you can use when you have the square root of a negative number is basically lose the negative and tack on an I. If we have the square root of -8, that's the square root of 8 times I. And then we can clean up the square root of 8, which is 2 times the square root of 2, since it's 4 times 2. So keep in mind, I is just a symbol. It lets us get in and do some algebraic manipulations with those non-real numbers. So we can do some calculations even though they aren't real numbers. So something like the square root of -6 times the square root of -6. We can split that up. -6 is 6 times -1. And -6 is 6 times -1. So basically, again, the square root of -1 is going to be our I. And so I've got a square root of 6 times I and a square root of 6 times I. So pulling those together, I've got a square root of 6 is a real but irrational number. Square root of 6 is a real but irrational number. And then I have I times I. So the square root of 6 times the square root of 6 is the square root of 36, or just plain old integer 6. I times I is I squared. And then you might remember we've defined I squared as being -1. So 6 times -1, this becomes -6. That's certainly cleaned up nicely. Kind of interesting, you can multiply two non-real numbers and then end up with a real number. What you want to be careful though is not to do this, writing the square root of -6 times the square root of -6 as being the square root of -6 times -6, because -6 times -6 is 36, giving us +6, and that is not actually true. The reason why, the rule that allows us to combine two radicals and multiply them together inside one radical only works if we're working with square roots of positive numbers, with real numbers. And so we couldn't join these two back here, the square root of 6 and the square root of 6, until we had gotten those negatives out of there. And then we can take the square root of 6 and combine them together. So, product rule does not apply to non-real numbers. To multiply square roots of negative numbers, we're going to first rewrite everything using I and then simplify. So what we need to do is fish that square root of a negative out of there. And again, doing it the long way, negative 3 is 3 times negative 1. Then we can pull this apart. Square root of 3 times the square root of negative 1. And again, by definition, square root of negative 1 is I, so that's been dealt with. The square root of 27, the square root of 3, these are both real numbers. We can combine them inside one radical, 27 times 3, and our I sitting out there. This gives us the square root of 81, and the square root of 81 is simply 9. So final result then is 9i. So using the shortcut on this one here, square root of negative 10 is going to be the square root of 10 times I. Square root of negative 2 would be the square root of 2 times I. So again, losing the negative inside the radical, tacking on the I. Saves us a little bit of writing. Then we can combine our real parts and our non-real parts. So we've got a square root of 10 times 2, and we've got an I times I. This gives us a square root of 20 and I squared. 20 we can clean up because it is 4 times 5. And do you remember what I squared equals? Negative 1. So square root of 4 is 2. The square root of 5 we can't really do anything with. And then we're multiplying by negative 1, so we can simplify this to negative 2 square root of 5. It's a lot of symbol manipulation, but none of it's too bad. And kind of a side note here, we've got all these different types of numbers, integers, rational, irrational, real, non-real. And just wanted to kind of draw you a picture to try to pull some of this together. We have our integer numbers. Integers are the whole numbers and the negatives. So these are things like negative 2, negative 1, 0, 1, 2. Those are all integers. Rational numbers are any numbers that can be written in the form of a fraction. So like 1/3, 7/8. Any integer, like the number 2, can be written in the form of a fraction. 2 is the same as 2 over 1. So all integers are also rational numbers. So let's throw a few more rational numbers in here. 1/3, negative 7 over 23. Combine them with the integers, and we get the rational numbers. Separate from the rational numbers are the irrational numbers. So they're kind of over here. Irrational numbers are still real numbers. We can locate them on a number line. We can cut a piece of string the square root of 2 feet long. So the irrational numbers are numbers that cannot be written as a fraction. Or another way to define them, rational numbers, if we convert them to decimals, will always be whole numbers or terminating decimals like 0.5 or repeating decimals like 0.333. Irrational numbers, if we convert them to decimals, those decimals will go on forever and not repeat. So pi is an irrational number. Square root of 2 is an irrational number. They're still real numbers, but they're in a different world than the rational numbers. So here are the irrational. So if we take the rational and the irrational numbers together, those are all what we call the real numbers. All of these numbers can be located on a number line. Separate from the real numbers, of course, the non-real numbers, all our i's, or multiples of i's. So, non-real don't exist on a real number line in their own little world. But if we combine the real and non-real numbers, that gets us into what we call complex numbers. So anything that can be written as a plus bi is a complex number. With the a plus bi, if a is 0, we simply have bi. I'm saying that badly. Okay, so if a is 0, a plus bi is simply bi, which is what we call an imaginary number. If b is 0, then a plus bi is simply a, which would be a real number. So all real numbers are also complex numbers. But not all complex numbers are real numbers because they are imaginary numbers, the non-real numbers. That may have been a little more detailed than you wanted. Okay, back to our symbol manipulation. We can add or subtract complex numbers, and we can multiply complex numbers. And a lot of it's similar to working with like terms in foiling binomials, things you already know how to do. Just keep in mind that I squared is equal to -1. That allows us to do some simplification on some of these. So if we want to add the complex number 5 plus 2i to the complex number 3 subtract 4i, just think like terms. So the 5 plus 3 are like terms because they're both real numbers. And the 2i and the subtract 4i are like terms because they're both complex numbers. Sorry, imaginary numbers. And so we combine and we get 8 subtract 2i. 2i subtract 4i is -2i. Subtracting, same sort of thing. We're just combining like numbers. We, of course, always have to be a little extra careful with the subtraction. Let's distribute that through first. 5 plus 2i, subtract 3 plus 4i. And then we can combine our like. So here's our 5 subtract 3 are both real numbers. 2i is an imaginary number, 4i is an imaginary number. Combining 2 plus 6i. Not so bad, is it? Okay, multiplying. We're going to have to do some foiling here because we're taking essentially a binomial times a binomial because they're two-part numbers. So if we foil here, 5 times 3 for 15, 5 times the subtract 4i for a subtract 20i, 2i times 3 is 6i, 2i times -4i would be -8i squared. That I squared is important. Don't lose it. Combining like terms, the -20i plus 6i would be a -14i. Do you remember what I squared is equal to? -1. So now we've got 15 subtract 14i. This will give us a plus 8, and we've got two like terms to combine still. The 15 and the 8i are both real numbers. We can combine them. 23 subtract 14i. So essentially, again, we're foiling, just like with the binomial. We just have this extra little thing to watch out for. The I squared becomes -1, gives us a couple more like terms to combine. Okay. One more here, 3 plus 2 subtract I. And I'm just going to expand that out a little bit and make it 2 plus -1i. You might not need that extra step, but I think some of you will be happier doing that. And then we've got the 3i and the -1i are like terms for 2i. And then we can bring down the 2 for plus 2. It's just traditional to have the real part first and the imaginary part second. And just a couple here to be careful not to mix up. 3 subtract 2 subtract I, and 3i times 2 subtract I. So for subtracting, again, take the time to distribute that subtraction through, then combine the like terms. So this will give us -2 plus 4i, whereas this one, it's 3i that's being distributed through the parentheses. So 3i times 2 is 6i. We don't need like terms to multiply. 3i times I will be 3i squared, and then we need to bring down the subtraction. So we've got 6i subtract 3. I squared is equal to -1. Subtract 3 times -1 would give us subtract -3 or plus +3. And then again, customary to write the real part first, the imaginary part second.